Hello, welcome back once again. Today we have this interesting improper integral, and in this video we're going to learn how to evaluate such integral. The integral as x goes from 1 to infinity of 1 over x times square root of x squared minus 1 dx. So let's see how we're going to solve this problem. First of all, I'm going to do a very nice transformation here. I want my integral to go from 0 to 1. So how exactly am I going to achieve this goal? So first of all, let's call this integral I. So I is equal to the integral from 1 to infinity. So we can write that as 1 over x multiplied by 1 over the square root of the quantity x squared minus 1. Then I have my dx here. Now for us to make this transformation, now we're going to make a substitution. So we're going to let 1 over x equals another variable, let's call it y. If we cross multiply, you will see that x is also equal to 1 over y. Now we can differentiate both sides, so we get the x is equal to negative 1 over y squared dy. Okay, now let's talk about the limits. So as x is approaching 1, that is this lower limit here, y will be approaching 1 over 1, since y is equal to 1 over x, right? So that will give us 1. So as x is going to infinity, y is going to 1 over infinity, and 1 over infinity tends to 0. So now we have our new limit. So our integral I is now equal to the integral, as this time around we have a new variable, that is y. So y is going from 1 to 0, right? Then we have 1 over x is already y. Then times 1 over the square root of x squared will be 1 over y squared, right? So we have 1 over y squared. Then minus 1 here. Our dx is negative 1 over y squared dy. Okay, now from here we have this is equal to, now we're going to flip the limits, right? So we switch the limit from 0 to 1. As we're switching the limit, there will be no negative sign here anymore, right? So now we have y multiplied by 1 all over. So this one here is same as 1 minus y squared all over y squared, just to make a common denominator there, right? Then this will be multiplied by 1 over y squared dy. Okay, so from here now, I will be equal to the integral from 0 to 1. So we have up here y, right? So divided by that square root there, we can rewrite as square root of 1 minus y squared. Then divided by, we have another square root of y squared, right? Then we have multiplied by dy over y squared. So this is equal to the integral from 0 to 1. We have y all over. So here we have square root of 1 minus y squared, then divided by y from here. So multiply by dy over y squared. Okay, so from here now, I think we have nice cancellations. So our integral I will be equal to the integral from 0 to 1. So up here we have this and this will be multiplied together, right? So that will give us y squared up here, divided by the square root of 1 minus y squared multiplied by dy over y squared, right? So are you seeing this cancellation? This get rid of this, right? Okay, cool. So now our integral is now equal to the integral from 0 to 1 of 1 all over square root of 1 minus y squared dy. Now I'm not gonna make use of trigonometric substitutions, so all I have to do here is to make another u substitution. Okay, so we're going to let y squared equals u, right? So we're not taking the square root on both sides. Y is equal to the square root of u. Okay, and from here differentiate both sides, we get 2y times dy is equal to du. Divide both sides by 2y, we get dy is equal to du over 2 times y. Y is already square root of u. Our limit will remain the same, right? So our I now will be equal to the integral from 0 to 1. So we have 1 all over the square root of 1 minus u, right? Multiplied by dy is du over 2 times square root of u. Take note of this. 1 over square root of k is same as k to the power of negative 1/2. You get the idea? So we're going to use that now to rewrite the integral. So we have I is equal to 1 over 2 multiplied by the integral from 0 to 1. So this is same as u to the power of negative 1/2 multiplied by this one as well, 1 minus u to the power of negative 1/2, then multiplied by du. So now we're going to make use of a special function. And what is that? The beta function. So we know the beta of m times n is equal to the integral from 0 to 1. We have x raised to the power of m minus 1 multiplied by 1 minus x to the power of n minus 1 dx. So we're going to use the beta function here now. So we have here I is equal to 1 over 2, the integral from 0 to 1. So this one is u raised to the power of 1 over 2 minus 1 multiplied by 1 minus u to the power of 1 over 2 minus 1, then du. And make use of the beta function, we get 1/2 times the beta of 1/2 comma 1/2. Now how can we evaluate this properly? Now we're going to use the relationship between the gamma function and the beta function. Okay, so we have this relationship that the beta of mn, right, that this is equal to the gamma of m multiplied by the gamma of n divided by the gamma of m plus n. The gamma function is just the extension of the factorial. Here is the integral representation of it. So the gamma of n is equal to the integral from 0 to infinity of e raised to the power of negative x times x raised to the power of n minus 1, then dx, if I'm not mistaken, right? Oh, that should be correct, right? And we have this, that the gamma of n is equal to n minus 1 factorial. You get the idea? Okay, so we have some nice numerical value of some of these inputs of the gamma function. The gamma of half is square root of pi. So we have this, and we have the gamma of 3 over 2 is equal to square root of pi over 2. So now using this relationship now, so we have our I already, we arrive at 1 over 2 times the beta of 1/2 comma 1/2. So this will be equal to 1 over 2, then multiply by the gamma of 1/2 times the gamma of 1/2, then all over the gamma of 1/2 plus 1/2. So this is equal to 1 over 2. Sorry. So gamma of 1/2 is square root of pi multiplied by the square root of pi all over this sum here is equal to 1. So the gamma of 1 is 0 factorial, which is 1. So I now is equal to square root of pi times square root of pi is pi, then over 2. And here we have the correct answer. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to my channel. Also like, comment and share.